All right, guys, almost spring break, almost made it. Today we got solving exponential equations. This could be one of the shortest videos of the year, so take advantage. Make sure you get the question right, but make sure you watch this one. Oh my gosh, here we go. Here's the core concept. If b is a positive number, and that's the case if the bases are the same, the only way that equation can be true if the bases are the same or if the exponents are the same. So like if you look at that right there, if 3 to the x equals 3 to the 5th, I mean, think about it. X has to be 5 because the base is already equal, so that means the exponents must also be equal. I'm going to show you 3 examples, and that's going to be the video. And here we go. 3 to the 3x plus 3 equals 9 to the x. The first kind of problem we're going to do is we're going to try to find the same base when we can. So what that entails is there's a 3, there's a 9. I would like to make them both the same number. And when we do that, what we're going to do is we're always going to make the bigger number become the smaller one, or break them both down. We're not ever going to make a 3 become a 9, because 9 is really 3 squared. Okay, so I'm just going to rewrite it like that. So I have 3 to the 3x plus 3 power on the right-hand side. Remember, when you raise one exponent to another one, you multiply them, so you get 2x. Now, here's what I have. I have an equal sign, and I have the bases are equal. So I already know the 3's are equal. I don't care about that. What I need now is I need the exponents to be equal. So I'm just going to set the exponents equal to each other. Move that 3x over. That's negative x, which gives me x is negative 3. And I promise you, if you plug that back in at the top, there's your solution. So first kind of problem we're going to do is we're going to find the same base. And once we get the bases the same, we're just going to set the exponents equal. I'm going to show you one more that was a little tougher. Okay, here's 2 more. Last slide of the video, by the way. Okay, I have 100 and I've got 1/10. Now I need to make them both the same. So I'm actually going to change them both this time into 10. Okay, so what I know about 100 is it's 10 squared to the x power. Now, if I want to make the 1/10 become a 10, I got to flip it, which means I got to put a negative exponent there. And that's about as hard as it's going to get. That's pretty good right there. Okay, so I'm going to multiply the exponents together. That's 2x. Multiply these exponents together, negative x plus 3. And now if you look at both sides, I have 10 both sides. Don't have to worry about the 10s anymore. Just going to set the exponents equal to each other. Move that x over there. And I get x is 1. And I promise you, I'm just checking right now in my head, looks perfect. All right, so that's the first type, is you got to find the same base. Now, the question becomes, what happens if you can't find the same base, like part B right here? When we get a situation where we cannot find the same base, we got to do the inverse of an exponent. And the inverse of an exponent is a log. So I'm going to do log of both sides. I'm going to do log of this side, and you can do ln. It doesn't matter, either ln or log. Notice I'm using base 10. ln is base e, obviously. The reason I'm using those is because that's what the calculator does. All right, now, don't forget our properties from yesterday. The x is the exponent. It's going to go in the front, just like that. And then to solve for x, I'm going to divide both sides by log 2. So I get log 7 divided by log 2. And I just got to punch that in my calculator, and I'm punching it right now. I'm getting about 2.807. So, and that makes sense because think about it. 2 cubed, 2 to the 3rd power is 8. So it should be a little bit less than 3 to get to 7, which is what I got. I got 2.807. All right, so that makes complete sense. All right, guys, that's it. Exponential equations tomorrow. We're either going to find the same base or we're going to log both sides. I'll see you tomorrow.